the hole. And the sun is shining through the hole and sending a spot of light down in the shadow. And you can see the shadow down there of where the shadow of the foil is. But part of that sun's image is beginning to cross onto the meridian arc, projecting an image that those who are far enough this way can see. And because the height of the sun changes each day through the course of the year, because the Earth's axis is tilted, we get the sun changing its height and sending that spot to a different angle on the meridian arc. Down here, summertime in June, the 21st or so. Up there, December 21st, the winter solstice. The shortest day of the year, the lowest sun, and of course the low sun means that you get the spot high on the arc. Now, with all of that, you would congratulate me and say, look at Griffith Observatory. You've got Stone Age astronomy, Bronze Age technology, a little Renaissance ornamentation with these zodiac constellations and stuff. But in fact, it is the 21st century. Because if everything works, as that spot of light, that projected image of the sun, moves right to the meridian, it encounters these little dots. And these dots are sensors. Those sensors capture the light of the sun as it moves across the meridian arc. And if everything works right, it will illuminate the constellation in which the sun is located and its place on the ecliptic chart. The stars that are up there in the sky that you cannot see have appeared. Here's the sun's position at its lowest point on the ecliptic, the sun's path, and the stars that are illuminated are the stars of Sagittarius the Archer. If you could see the sky darkened with the sun still up there, those stars would be right where the sun is right now. Well, you know, nature isn't that kind, and it is not allowing you to see those stars of Sagittarius. But Griffith Observatory is generous and is delivering these stars of Sagittarius to you anyway. Now, as the sun's image continues to move across the meridian, you're seeing the Earth turning. That's the rotation of the Earth right before your eyes as that image of the sun gradually moves. And once the image of the sun gets off of these sensors, of course, local noon then is over. And then it's afternoon. And it's almost time to go into Griffith Observatory. That would seem to suggest that that's really all there is to this story. End of the Maya calendar, winter solstice, and low sun, local noon, and all that. But wait, there's more. I need to know where you folks have come from. I need to know who has come from the greatest distance to reach us here today. So anybody who thinks they've come from a really far away place, let me know.
Korea.
Korea? Okay. Anybody farther away from Korea?
Australia.
Australia beats ya. Anybody farther away from Australia? Is Australia it? Mars. How can you breathe? So much oxygen in the atmosphere. All right, Australia is going to have to assist us today because this is the winter solstice. And at the two solstices each year, we have to make a modification of the meridian arc. If you think about it for a second, the sun moves up this way for half the year and then moves back down the arc on the same position for the second half of the year. How does the chart know whether we're going up the arc for those dates or down the arc for the other half of the year in its dates? The way the chart knows the answer is by us throwing the big solstice switch. And that's what you're going to have to help us do, is throw the solstice switch. So as soon as our stars go off, got about a moment left. And local noon is finished at Griffith Observatory. Now may I have the assistance of our Australian visitors? Yeah. You know, I'm actually quite impressed with these folks. They come from Australia, that's the southern hemisphere, and here they are. In the northern hemisphere, all the blood is rushing to their head. They're upside down, but nonetheless, they're able to do this task. Good work. Okay, so you pick up, both of you, get a grip, and all you have to do is throw it over there. Give a drum roll, please. All right, we are ready for the second half, or really the next half of the year. And at the same time, you were at Griffith Observatory, at Baktun 13's closure. And you know what happens after Baktun 13 in the Maya long count calendar? Exactly! Thank you very much, Griffith Observatory. I was delighted you're here.
I took a few, but writing the sign, so I couldn't get it.